My name is Rick Hooper. I'm the president of WRF-Hydro, and I will be introducing our seminar speaker today, who's Witold Krajewski from the University of Iowa. As we get started here, though, I wanted to make a few comments about the applications which are going to be due this Friday. And this is also an opportunity, if you have any questions, to ask questions about the application process. You can type those into the chat box. We will be doing a quick overview of the application procedure. Then we'll have a talk about the subsequent NFIE webinars coming up later this month. And then the WRF-Hydro training class, which is going to be offered jointly by Quasi and NCAR. And then we'll have our presentation by Dr. Krajewski. The application process, the applications are going to be due. The deadline was extended until this Friday, and applications have been coming in. So present or prospective grad students and postdocs are eligible to apply, and there are 3 different categories. This is a little complex, but it sort of has just arisen that way that there are some complications. We have 3 categories of participants. We have what is called the Summer Institute Fellows Program, and that's going to be a residence in Tuscaloosa from June 1st to July 17th, primarily working at the National Water Center. That was the building you saw on the preceding page, a very a nice facility that's just opened up in Tuscaloosa. And because of restrictions of this being a federal building and the fact that we're trying to do this with a very short time line, at this point, this is open only to U.S. citizens, and that has to do with residents at the National Water Center. We also then will have the NFIE Summer Institute Resident Scholars Program, the same dates in Tuscaloosa, with the primary location being just down the street at the University of Alabama, so on campus at the University of Alabama, rather than at the National Water Center. And this Resident Scholars Program is open to international students. And then finally, we want to try to support visiting scholars that would visit Tuscaloosa on June 1st to 5th and the 15th and 17th, and to participate remotely in this. We realize that some students may not be able to get away from their home campuses or have other obligations. The idea here would be to work under the guidance of a mentor at your home institution and participate in weekly webinars. This is open to U.S. citizens and international students. Application information can be found at that web address, www.quasi.org/NFIE. The application consists of a completed application form, a 1-page CV and your transcript, and either a statement of intent for the Fellows and Resident Scholar programs or a project description for the Visiting Scholars Program. The idea of the project description is just that for those of you that will be working remotely, that you have an initial idea of what you would like to accomplish during the summer. So it's very important to provide a project that can be substantially completed during the 6 weeks of the NFIE. We need a letter of support from your advisor, and then compile all those documents into a single PDF and send to the address on the screen, commanager@quasi.org. All this information is contained on the website. So what's the award consist of? For the Fellows and Resident Scholar programs, you will get travel support to cover the cost of round-trip transportation to the University of Alabama, participation in the kickoff and capstone event, suite-style lodging and meals during the Summer Institute on campus at the University of Alabama, participation in all the NFIE trainings and events during the Summer Institute, and access to the NFIE mentors and instructors. For those on the Visiting Scholar programs, you will get the travel support to attend the kickoff event, and then travel support to cover the cost of round-trip transportation for participation in the capstone event, pending an abstract submission midway through the summer, that you're ready to present some results. Again, then suite-style lodging and meals while at the University of Alabama, and then remote access to the NFIE mentors and the instructors. So this is a brave new world. We're trying this. This is will be an interesting exercise. We think we have our act together to do this well, but this clearly is experimental, and we're trying to see how this will work, and we're hoping that you would be join us in a sort of the spirit of discovery as we try to put this together. Dates and deadlines, March 6th, the applications are due. That's this Friday. March 31st, we'll have a decision from Quasi, the steering committee, will be released to the applicants of what everybody has received. During April and May, we'll try to begin to form project teams to get a head start in this. And then June 1st, the Summer Institute begins. The next NFIE webinar will be Wednesday, March 25th at 3 p.m. Eastern Time. Will be updates from the spring meeting with additional details. Will be discussed, and there will be an opportunity to ask questions again. So one new thing we want to bring to your attention, which is quite relevant to the NFIE, will be that WRF-Hydro training will be provided. WRF is the Weather Research and Forecasting Model, which is operated out of NCAR. So this training is sponsored by Quasi and NCAR. WRF-Hydro is a coupling environment between this weather model and a hydrologic model. And in particular, we'll be looking at the RAPID model. Cedric David from JPL at Caltech will be one of the instructors of this meeting. This is one of the hydro models that have been coupled with WRF. This is a 2.5-day workshop on the use and applications of the community WRF-Hydro modeling system. Grad students, postdocs, and professionals working in hydrology and atmospheric sciences are invited to participate in this. Registration will open Monday, March 9th. This will be a very short registration period. So if you're interested in this conference or in this workshop, please sign up soon. There are some travel grants available for graduate students and postdocs. We have $500 travel grants, which will help defray the cost of the travel and tuition for the meeting. And so more information is available off the Quasi website. Let me stop there for a second and take any questions. If anybody has any questions about this, please start typing so we know you have a question coming up, and I'll slowly I'll move on. But if you have any questions on the application procedure, now's a good time to ask them. I don't see anything coming in right now, so I think we will move in next to our presentation for today by Professor Witold Krajewski. He's the director of the Iowa Flood Center at the University of Iowa. He will be speaking on the Iowa Flood Information System. This is a very advanced information system that has been developed in Iowa. It's a great example of the kinds of technologies we want to bring to bear at the NFIE. And with that, I will turn it over to Vitek.
Yeah, thank you very much, Rick. Welcome, everybody. Thank you for joining us and for participating in this webinar today, which is supposed to provide another piece of information towards the NFIE objectives. So you may wonder why Iowa, and are all the other states going to present similar, systems? Well, this will not be, the case. You will hear from us because we have been building, a system similar to the one that we would like to help build for the entire, country. So in 2008, we had a historic event. Flooding affected big parts of Iowa. You see here in this picture the city of Cedar Rapids. That's about 300,000 inhabitants. So, not a big city, but big enough. You can see what happened. Off to the left, there were 10,000 city blocks affected, 10,000 houses affected by this flooding. So a major event. The flooding was widespread, also affected the city of Iowa City, which is about 30 miles south of Cedar Rapids. This is where the campus of the University of Iowa is, and the campus itself was also affected in a major way. How major? Well, the most recent estimate of the total recovery cost is approaching $1 billion. So that's serious, money. Well, perhaps, the fact that the campus was affected and this, coupled with the recognition that here on the campus of the University of Iowa, we have one of the oldest hydraulic institute in the nation, with some 90 years of history and expertise in hydraulics, fluid mechanics, and river mechanics. So those two facts, combine and led to establishment of the Iowa Flood Center. So the legislators of the state, they recognized that we have some expertise and that we can help the people of Iowa to deal with future floods, and this is a full wording of a House file that established, the center. I don't expect you to read all of this, but perhaps just, a couple of, keywords. So you can see that the legislators charged us with certain expectations. So we remain an academic research, center, but there is a gentleman's, agreement, here that we will be helping the people of Iowa, and we do. We don't have a separate, facility. We are housed in this iconic, facility of what is called today IIHR, Hydroscience and Engineering, which is, the home of that, world-known River Mechanics Institute. Now, I will organize my presentation following the paradigm that was proposed by Professor David Maidman from University of Texas when he presented the NFIE, and he conceptualized this into 5 components, and they are listed, here, and you see the interactions, how those components, fit together. Well, when we started our work at the Iowa Flood Center, we didn't have, this paradigm. However, it really wasn't, too difficult, for me to organize the presentation following, this schematic. So this is what you will see next. So I will have 5 sections to this presentation, and I will start with NFIE Geo. And NFIE Geo is about organizing a drainage, network infrastructure, so that infrastructure is digital, of course. And this is because of the recognition by Professor Maidman and many others, but maybe not everybody, that this is how water flows in the environment. So if you want to mimic water flow, well, then you have to have this digital representation of the pathways, how water flows, at least, on the surface. Well, and to tell you where we are in building this infrastructure, I have to take you to another activity that we are following, here, and this is what we refer to as a mapping, project. So during the flood of 2008, there was a recognition that the flood inundation maps for the state were outdated and they were difficult, to find. And basically, this was a major, shortage of information that affected how people responded, to the flood. So, following, the flood, federal agencies they send funding, to the state, and the state organized a project between the Iowa Flood Center and the Iowa Department of Natural Resources. And we are basically mapping the entire, state. And we do the technical work, and Iowa DNR, they communicate on the administrative aspects of the project with FEMA, which is the major agency that is involved here on the federal side. So this project is organized into 4 phases. But before I show you those phases, I have to say that even before the flood, due to the wisdom of our local agencies, we were collecting already statewide airborne LiDAR data. So today the entire state is covered by 1 meter resolution digital elevation model. And so you can see, just spectacular images that come out of this data set. So this is a major resource that we benefit from. Now the mapping, project is organized into 4 phases. So now those are not the NFIE phases; those are the phases of our flood inundation mapping, project. So the first phase, which here we call hydrography, it corresponds more or less directly to NFIE geo. The other phases include what we call hydrology. So basically that's the regional flood frequency formulas coming from USGS. And then with those and the terrain data, we set up calculations of how water flows in the channels. So we have to provide cross sections and provide this digital infrastructure for the hydraulic models, run the hydraulic models, and then convert the water surface elevations into maps. So that's the last phase, the mapping phase. So so with this background, I will go back to NFIE geo, which is hydrography here. So one can ask, okay, so why don't you just use the NHD plus data set that is available for the whole country? And this is what Professor Maidment recommended for nationwide implementation. Well, I would like to show you in the next few slides how this particular data set would fit with what we have done here and where we are heading. So these are the NHD basins. I don't have a scale here, but roughly you are looking at 5 by 6 kilometer domain. So so now if I take one of those basins, and then I add the so-called blue lines here, this is what we have in NHD data set. Well, this was not sufficient for our purposes because we had this dream that we need to develop a more detailed network that mimics how water flows in the environment. So of course there are smaller units that collect surface runoff and organize it into runoff at larger scale. So we used 90 meter DM data to extract the drainage network, and this is what you see. So those are those darker blue lines. And then for those lines, we organized hill slopes that drain surface runoff into those channels. So what you can see here is that, and we have this implemented for the entire state. So, but what you can see here is well, that we approximately fit with NHD, but not very well. Our network, even though maybe one can argue it's more detailed than NHD lines, but it's really not, that impressive. And you can also see that we have this smaller scale partitioning of the landscape, smaller than the NHD basins. Well, we recognize the shortcomings of all of this, and we work on taking advantage of the LiDAR data that we have, and refining both the network as well as the representation of the hill slopes. And so in the next few slides, I will show you what we are in the process of doing. So here you see the shaded relief based on 5-meter LiDAR DEM, terrain data, and on that background, the 90-meter based extracted network, the same one that I was showing you before. Well, if you just go to 30-meter DM, of course, the fit into the terrain will be much better, and here it, comes. So it's already, pretty good. Now, if you go to 5-meter DM, so just resampling that 1-meter DM that we have for the whole state, well, this is what you get. So here you have, pretty nice fit of the drainage network into the terrain, and on that basis you can then add additional elements. So, but now these thicker blue lines that I'm showing you here is the network that actually corresponds very well with the NHD blue lines. We have refined this through our mapping, project, so there are slight differences, but basically this is what you see. And again, this network is not sufficient for our purposes, so we have to complement it with this finer scale, network. And so you see it, here together with a set of hill slopes here shown in these different, shades of green. So, and now just to remove some clutter, I can show you for the same domain all the hill slopes that we have in this particular, domain. So, so we are now working on bringing, this to the entire state. And this is what takes me to the next element of NFIE, so NFIE-Hydro. And, I have Iowa here in parentheses because, again, we already have a statewide rainfall runoff model that does flow forecasting everywhere. So now, based on this 90-meter DM network, extracted, network that I was showing you before, and all the corresponding, hill slopes, we have a system of some 600,000 differential equations that forms, this model. And of course, going into finer network representation quickly translates to millions of hill slopes and therefore millions of equations for the model. So, well, we'll talk about solving, this massive system of equations very soon. But for now, just another look at this landscape decomposition into channel links and hill slopes. So, and of course, we realize that the rainfall to runoff conversion happens at the hill slopes, and then the drainage network routes that surface, runoff to larger and larger, scales. And again, based on what we have right now, these hill slopes are roughly 10% of square kilometer, with channel links roughly, a few hundred, meters in length. And one can, refine this, and this is what we are working, towards. Now, very quickly, without any details about the hydrologic, model. So again, there is this conversion of runoff into of rainfall into runoff, and of course you have to account for different storages and how water in those storage compartments communicates with each other. And that communication could be through a set of linear or nonlinear, functions. But everything is organized along that landscape decomposition that I discussed. So now I'll just show you an example of a slightly larger basin than before. So this is about 4,000 square kilometers, the so-called Turkey River Basin in northeastern Iowa. So you see a nice representation of the network, and if we zoom in into that lower highlighted squarish area, this is what you will see, and even without stretching your eyes, you can see that there is a very nice fit into the terrain. And so here you just see the drainage network. This is just another close-up here. So now you see from Google Earth the fields and roads and little towns in Iowa and so forth. And again, a nicely fitting drainage network. Now, if you add to this hill slope elements, well, then you have a complete representation of the model. And of course, each of these areas, they have their own characteristics that describe soil hydraulic properties, geometry, land use, and so forth. Now, so just an important qualifier here, that we don't resolve, further these elements, but of course one could. So one could have, 10-meter finite element representation of those, but they should fit those shapes that we are presenting, here, because those shapes fit the drainage, network, and the drainage network does fit the terrain. So that's how any other model really should be constructed. Now, the general framework for this model is shown, here. So you can represent, different, processes. This is a little bit more general than what we actually have implemented. But you can play with different, components. You can easily use different, functions to describe, these components, linear, nonlinear, and then all of them are solved using the same numerical solver. So we have organized our work so that model equations and the solver, numerical solver for those equations, those are two separate, things. But of course, there is a requirement that the system is organized, the system of equations is organized as a system of ordinary differential equations that are organized by the topology of the drainage network and the corresponding, hill slopes. So, of course, to have a hydrologic rainfall runoff, model, you need to provide the rainfall. Well, some of you may know that we do have such, expertise here. So we get basic data from 7 radars that cover, the state of Iowa, and we convert those into rainfall, maps with the resolution of roughly half a kilometer and with temporal resolution of about 5 minutes. So every 5 minutes we have a new map, and then if you look at the statewide scale, then you can see these storms zooming across the state. So here you have the 7 radars that cover the state. The one in the center is one in Des Moines, the capital of the state, and there are other radars that are outside of the state but cover good chunks of the state. So we got rainfall, and we got the model, and we can then make forecasts of the stream flow. And of course, when that stream flow amount is too much for the channel to handle, well, then you have a problem. Then you have flooding. So now to represent what happens in the channel, the NFIE framework calls for the NFIE component NFIE river. And so here, of course, we also recognize that this component is important, and so I will tell you now a little bit more about this. This kind of detailed representation, as you see here, so you see the supports of a bridge without showing a bridge, deck, and then you see the bathymetry of a channel, somewhere in Iowa. Of course, this kind of digital representation is not possible for widespread implementation at this point. Instead, what is possible is a much simpler representation through cross sections, and many of the open channel flow models, they require such representation of the cross sections. So, and of course, for the mapping project that I was showing you at the beginning, we do have such a representation. It is not completed for all the streams and rivers in Iowa simply because the project is still ongoing. We are about 70% done. The project will be completed in 2016, but big chunks of Iowa and many good-sized basins are done. And when they are done, then that allows us to have representation of flood inundation zones, together with several characteristics, most of which are relevant to flooding. There are some other ones that I will not be showing you here related to erosion and so forth. But clearly, when it comes to assessing flood impacts before or after the flood, depth is something that is critical, and also water velocity. We also recognize that there are that in engineering, the representation of flood risk is associated with certain probability of exceedance, and the engineering standards, design standards, and planning and insurance, that those are organized in the form of certain probabilities rather than the amounts of water. So one can then look collectively at these different inundation zones, for example, in this particular way, and again, this is similar to what Professor Maidment was showing before. So now these single cross sections that I was showing you before may be adequate for certain purposes, but may not be quite adequate for other purposes where more detailed representation of how water flows in the channel and outside of the channel is required. So we have our own facilities. This is a research boat, costs probably like a couple of Ferraris. But it can take data like I was showing you before, so you can collect information on the bathymetry with pretty much any level of detail as you wish, with the limit of roughly 1 inch or so. Well, this is mostly not that important for flood mapping, but there are these places where we don't know much about where the bottom is, so it is useful to have a facility like this. And we have used this facility to map sections of rivers near the largest communities in Iowa. And so you have here a map of locations of what we call detailed inundation maps. So this is outside of that statewide mapping project that I was describing at the beginning of my talk. So here, for each of these communities, we developed a number of maps, and we indexed them actually not only by these probabilities of exceedance, but also by the water surface, elevation. So we developed so far thousands of these detailed, maps, and we present them through our web portal so that the people of the state can benefit from them. These maps can serve as a translator of what the media repeat after the federal agency. So, for example, you can hear something like this, that it is projected that the stage at such and such river and such location will reach 26 feet. And you hear this when you are driving, and it really means nothing, to you. So it is only when you come to this software that we developed and you dial up. Let's see if I can. Well, yeah, you have to look at the sliding rules, and so you can dial up the given, stage, and then the inundation will be shown. And so this is the translator of something that has really little, meaning to a casual, person, to something that has very specific, meaning, because this is in a Google Map environment, so one can navigate this easily to find, their own business or house. So there's just, an example, another example for another location. So as you could see, we have developed these maps for a number of locations, and every year we add 2-3 new locations to this, set of inundation maps. And I will come back, to how we are planning to connect this very extensive mapping activity with the also very intensive flood forecasting activity based on the model that I was, showing. Well, but it's time to go to the next element of NFIE, NFIE response. Again, Professor Maidment, he invited, webinar, a fire, chief from the city of Austin. I don't have a person like this in my office, here, but we have worked extensively with different communities in the state, with people from both general public as well as with people who have formal responsibilities for the public, safety. And we have done this at the county, level for all 99, counties here in the state, as well with the state homeland and emergency management agency that has this responsibility in the state. And so, and one of the main tools that we have developed for them and for the public is what we call Iowa Flood Information System. So this is a quick clarification of the title of my talk, because here in-house, when we say Iowa Flood Information System, we mean browser-based platform that provides information to the public. That platform integrates many of the elements that I was talking about, the inundation maps, the hydrologic model, the rainfall, and a bunch of other things. So but when Professor Maidment, when he proposed this title for my seminar, I didn't really correct him, because in a broader sense I am talking about Iowa Flood Information System, broader than just a web-based portal. But a few words about this portal. You can just Google it and find the information. So there are all sorts of options. Every few months we come up with new features. This is available to the public. We try really hard to design it so that no technical expertise is necessary to navigate through and to get some useful information. So again, this system addresses a major shortcoming of the situation here in 2008. So perhaps most importantly, this platform provides a hydrologic context for what's going on. So, and it is this context that we really don't get in the media. So we all watch weather news, every day on every channel. There is even a channel dedicated to weather forecasting, but there is nothing, dedicated, to hydrology. So, and of course we all know that, for example, heavy rainfall that is falling outside of the river basin that is relevant to you, is not relevant to you. So it is important to have that hydrologic, context. You should, feel free to explore, the system. Right now there is nothing interesting going on in the state. The ground is frozen, so you will not see much. But this particular example here shows rainfall, and not only current rainfall, but through this system you can look at rainfall accumulation over the last few days. And again, we hydrologists, we know that rainfall that occurred maybe, say, 3 days ago may be relevant to you, because there is a certain travel time that is associated with basin size, and it is not wise to stop paying attention the moment when rainfall stops. So we provide this information in a very efficient way. And again, you can explore it on your own. We also provide some context for the amounts of rainfall, because again, people really don't know in a quantitative sense what is a lot and what is really not that much. So we use in this system probabilistic description of rainfall with analysis performed at the Office of Hydrologic Development of the National Weather Service, and we can put these amounts of rainfall at the daily scale into some proper perspective. So but roughly speaking, in Iowa, 7 or 8 inches of daily rainfall, that corresponds to this probability of exceedance of about 1%. So now another element of the NFIE response, again this is now NFIE Iowa, is the information on what is going on in the streams and rivers. So again, you may know that due to budgetary cuts over the years, the number of USGS stream gauges across the nation has reduced considerably. Well, of course, Iowa is no exception, here. So in 2008, there was a feeling that people who have responsibilities for public safety, they didn't know what was going on in streams and rivers. Well, we have addressed this by installing some 200 of what we call bridge sensors. So you have a device, ultrasonic, device with a sensor that is looking straight down. I have no control over the pointer, here, so it's right. So this is, of course, flooding, and so you see this beige color box with a cylindrical element pointing, down towards, the water. So I'll show you better pictures. So we have installed over 200 of those, and we are adding, more, and they complement the USGS, network. So all the green dots here are our, sensors. And the concept was simple. Wherever there is a road crossing a stream, there is a bridge. In Iowa, there are over 20,000 bridges, and these bridges provide already paid for access to the river infrastructure. And so we took advantage, of this and installed boxes like this. We built them ourselves. So this is from conceiving to deploying all the way through. These are autonomous devices, battery, solar panel, cell phone, the sensor, data management system inside, and so forth. You install them, you push a button, data come to our servers and off to the web portal. And so you can see the installation, here. And again, sometimes we had few cases where these got overtopped. So you see an example here. The boxes are sealed. We test them before we deploy them. When the water goes down, the device resumes sending, data. So this is pretty amazing. We are very happy to see this. And then, of course, yeah, the device submerged, then there is, no data. But anyway, so this provides very useful information about how from the bridge the water first is. We are working on developing rating curves for these places. Right now we have them, or at least they are not ready for prime time, but this is something that we want very much, and not only us, but also the agencies that are operating in the state. This is a fairly recent, example. So we had a warmer period here in February. The temperatures during the day were above the melting, level, and then freezing at night, and you see these diurnal fluctuations, here of the water table at some small stream. Actually, not so small. This is at Des Moines, River. So just an example of usefulness of the data. Again, another mapping example for some of these maps and communities by the depth. So again, these are all elements that go into this NFIE response. They provide information on what is going on. Now, the flood forecasting, model also is part, of that. So we provide forecasts for many locations. We do not provide forecasts for those locations where the National Weather Service provides, forecasts. But where they don't, well, that's a fair game. So we do. Perfect? No, of course not. But we have a complete end-to-end system that we continue working, to improve. We provide forecast for some 1,000 communities that are located within the state. Sometimes this is a quantitative forecast in some communities where there is just no way to relate to any quantitative information that we could provide. Like, we could say, discharge will be such and such, but what will people do with this? And if we have no rating in occurs, we cannot even give the stage. But even if we gave the stage, they still cannot relate, to this information because there is nothing to reference, this. So in those cases, we provide some simple index of flood potential. Well, how do we do this for the entire state? And just to remind you, so the state of Iowa is not that small. It's half of Poland. I'm from Poland. It's 150,000 square kilometers. So, so it's a good chunk of really state. And to do this for the entire network, takes, some doing. So we have developed a numerical solver that organizes computations in a similar way as water, flows. And so this just gives you an idea. We have, a paper documenting this. Now, what you see here is our future work. So this is a mock-up. This doesn't, exist yet. But this is, again, along the lines of the vision that Professor Maidment, presented. But we developed this some 4 years ago, this particular, mock-up. You can dial up where into the future you want to see, and then the corresponding, map will show you the streams and the sections of streams that may be or will be, according to our model, above some flood, level. And then, of course, if you go, further into the future, maybe all the little streams already responded. Water is like flowing back to normal, and only the main stem of the river is still, in danger. So this is what we are working on. I think that sometime this year we will have this system online. Well, so this is our team. So there is a number of people who work on this. We are, here, to help. We collaborate with state and federal agencies that have interest in Iowa. If the federal agencies that will be building this national, system, if they want to save taxpayers, money, well, then now they know where to come and ask for our assistance. So with this, I'm going to stop. There is much more than we have done, but I hope that this gives you an overview on a soft technical level of where we are in reference to NFIE. So thank you very much.
Excellent. Thanks so much, Vitek. That was a great presentation. This is Emily at Quasi. So now at this time, we'll go ahead and take some questions. Participant phone lines have been muted to reduce background noise. So if you have a question, go ahead and type it into your chat box, and I will relay it to Vitek. And as a reminder, this presentation is being recorded, and it will be posted to the Quasi website. So you can find the link from the NFIE page, which is www.quasi.org/NFIE, if you want to see it again. So we'll wait one moment while people type questions if they have any. So it looks like we have some typing happening. We can also take questions if you have any about the NFIE Summer Institute application, if you didn't get to ask a question at the beginning of the presentation. Or my email is in the chat box if you'd just like to contact me directly. Okay, so here's a question from Chris Vitek. What tools did you use to process the LiDAR data into hydro derivatives, like streamlines?
Well, so this was a combination of manual labor and some automated tools. So it developed in-house and also by our colleagues at Iowa State University. So, and of course, GIS is all a major tool that we use, but we didn't really use the standard GIS, tools for this purpose. Okay, so anyway, Emily, I will let you control the traffic. So
Okay.
what is the
So here's
next
another question from Jim Nelson. With your great LiDAR data resources, any thought of using 2D modeling? It always seems like using a 1D model with cross sections and then mapping is a step back from what is possible.
I agree, and this is one of the issues that we are, studying. To what degree different modes of water routing in the channels are necessary and for what purposes. So it seems that you have to select the model based on what is your purpose. We don't think at this point that it is necessary to run 2D models, everywhere all the time to make good prediction of floods. But there may be some special and local situations. Well, backwater effect. That's one example where this may be necessary. So. To some degree, it remains, an open question simply because in the past, we as the community, we didn't really have many opportunities to study this question at large enough, scales. I'll stop here.
Okay, great. And then a question from Alex. What is the DEM resolution in the HEC-RES model and distance between cross sections? What was the criteria?
Yeah, so we did use actually we used the 3-meter DEM to define this cross section. So again, the state has the 1-meter DEM available everywhere. 1-meter DEM is pretty noisy. So then we resampled this in a few different ways. 3-meter resampling for the cross sections, 5-meter resampling for that network that I was showing you. Now I have to get back to you on exactly what criteria we used, but the distance between cross sections is 200-300 meters or so. So, and of course it depends on the local situation, because we have to take into account the tributaries coming together, and some structures and so forth. So it depends, but roughly like that.
Okay, and there's one more question in the box right now. So again, if you have any other questions, go ahead and type them in. So Solomon asks, are the river geometry files from the IFIS publicly accessible?
So the short answer is no. And so there are several reasons, for this. So one is that many of the maps that we have already developed are still undergoing a FEMA review before they will become official, maps. So, so because of that, not all those resources are publicly available. Another good reason is that the way we have them organized right now is well, I'll call it less, than perfect. So this is another project that we are working on to organize them, better in a way that would be suitable for sharing. But I also wanted to mention that the new network and that we extracted for the purpose of the statewide, mapping will become a new NHD dataset. So not all the tiny little, things that I was showing, but the bigger, elements that we digitize for the purpose of the mapping that correspond pretty well, but refine the current NHD plus. This will be an updated NHD plus, and again, that process is ongoing.
Okay, great. Well, we are right at the top of the hour. Let's see. I see a little more typing. Oh, so Solomon says thank you. So, here's one question that just came in from Kiani. What programming level do you expect from the participants in the summer training program? So broadly, we do want some programming experience. And if you want further details on the programming level, we can discuss that via email. But on the NFIE application form, I think I do have this pulled up here.
Well, I can also address this as a member of the NFIE, committee. So both in our work as well as for the Summer Institute, I don't think there is or there will be one main language or skill. So all this work is a hybrid of many different tools. So for the Summer Institute, there will be a process of matching the current expertise and knowledge with the objectives of those short projects. So so there is no one hard answer to this question.
That's correct. And there is an opportunity on the application form to kind of describe, the programming languages and any projects that you've worked on. So any information that you can provide will be helpful. So with that, I think we'll go ahead and wrap up. We've gone over an hour now, but Vitek, thank you so much for your wonderful presentation. And if anyone has any additional questions, feel free to contact me. And get your Summer Institute applications in by Friday. We look forward to seeing the rest of those come in. It's certainly going to be exciting. So thank you, Vitek, and thank you all for attending.
Yeah, thank you, everybody. And thank you, Emily, for holding my hand. So.
Today. Okay.
Okay, bye-bye.
Bye.